In this video, we're going to be discussing the example, a ball is thrown with an initial velocity of 7 meters per second at 25 degrees above the horizontal off of a building. So we're sort of looking at the scenario where we throw the ball some initial velocity up in the air, and then it's going to fall down like this. And we want to know what the velocity the ball has just before it strikes the ground. And we know from here to here is 10 meters. So delta y is going to be 10 meters. Now remember, it's always just before it strikes the ground, so your answer is not 0. So that means that we need to find that final velocity. And it's asking for velocity, which is a vector. So we have to remember we need both magnitude and direction. Finding velocity final in the x isn't too bad, because remember the acceleration in the x direction is 0. So the initial velocity in the x equals the final velocity in the x. So all we need to do in this case is apply a little bit of trick. So velocity in the initial x equals velocity final in the x, which is v initial times the cosine of theta. So we're going to take 7 meters per second times the cosine of 25, and we're going to get 6.34 meters per second. So we have the x component of the final velocity. Now we need the y component. Now we don't have time, and we don't have delta x, so we can't find time in this case. So this means that we're left with using our one equation that doesn't have time. Velocity final in the y squared equals velocity initial sine of theta squared plus 2 times acceleration of y times delta y. So velocity final in the y's are unknown. We're going to plug in our 7 meters per second for velocity initial. We're going to take the sine of 25, and then we're going to take 2 times negative 9.8 meters per second squared, is always negative, times a negative 10 meters, because remember, we're initially at 10 meters, and we're falling down to 0 meters. So delta y is equal to 0 minus 10 meters, because it's final minus initial position. So that gives us a negative 10 meters. Alright. So that gives us a velocity final in the y direction of 14.3 meters per second, and because it's falling down, it's going to be negative. Because you're taking the square root, it doesn't automatically come out of the answer, but remember when you take a square root, there's always plus or minus option. In this case, we need the negative option. Alright, then to get our final answer, we're going to use velocity equals the square root of vx squared plus vy squared. So I'm plugging in my x component and I'm plugging in my y component, and that's where I get the 15.64 meters per second. And then to get theta, and I've drawn this over here, this would be vx, vy, and then v and theta. So we're looking at so many degrees below the positive x-axis, which would be the fourth quadrant. And we're going to use inverse tangent of vy over vx, which is how I got the 66 degrees, and I'm saying south of east because we're pointing east and sweeping south. So this is east, this is sweeping south. So you have to be very careful in these problems when I'm asking for velocity. Remember, velocity has both magnitude and direction, and when we're dealing with projectile motion, we're going to have an x component and a y component because it's taking a parabolic path, not a path that is directly in the x or directly in the y.